Hi. Hope you all had a great weekend. Just as a quick reminder, you've got an assignment out right now. It's HTML me something. I believe it's due on Thursday. Is that right? Or somewhere? I should have looked it up before class and I didn't. But it is due soon. I know that much. It's Thursday? Oh, cool. I was right. So hopefully you've gotten started on that. If not, today's probably a good day to get started on that. Let us know if you need some help getting kicked off. Otherwise, today is kind of an exciting day. We're going to start in on a big project today, a project that's going to take us the next 6 weeks or so to put together, and we're going to work on it together as a group. So I'll introduce that kind of towards the end of class today. But before then, I've got some questions for you about the prep work that you looked at before you came today. So let's have a chat about URLs. What are the main pieces of a URL? I guess I skipped the first one. What is a URL?
Kind of like a website.
Uniform resource, yeah. Location, something like that, yeah. It's an address. It's an address. We use them all the time. You go to fire up your browser, you type in facebook.com or whatever, and that's a URL, right? So what are the pieces? What are the main pieces of a URL? Protocol, all right. So an example of a protocol would be HTTP, or actually HTTPS, where the S stands for secure, right? Going to try and encrypt the traffic that goes back and forth, which is very important if you are sending sensitive information like passwords, credit cards, things like that. Okay, protocol. What else? The host. So what's an example of a host? Facebook, yeah. Google, right? So where am I actually going? That's called the host, or the host name. Anything else? The path. So what is a path? What's a path do for us? Yeah, in the back.
It's like the exact location of the file.
Yeah, so anytime you go to a website, anytime you are navigating a web page, you're actually requesting files. We're going to talk about requests in just a little bit, actually. So you're requesting files, right? And so the path is the specific file or the specific location of the URL that you are requesting. So if you open up a browser and go to, we could use this for example, or I don't want to show you my Facebook, actually. That's probably not a good idea. We can go to Google. So I can go to google.com, but then if I go to About, you can see that, it tacks on a whole bunch of stuff here, right? So international/English, so it's giving me the About page for the English version of the About page. So it's telling us exactly which part of the website we are trying to access. And actually these paths are very similar in concept to like something else that we've seen. Like what? Like the files on your computer. When you are on the command line especially, I feel like you can really see the similarities between the two, right? Using CD to navigate from one directory to another. It's really the same kind of idea that you see with the paths. Those are folders that organize the website. Those are directories that organize the website's content. And so if you're creating a website, I think that's something important for you to consider as well. What are the different areas of my website? How can I organize this content in an efficient way? Cool. Awesome. Any other pieces that I'm forgetting about? All right, let's talk about some other stuff with URLs then. I'm asking next, how do we include a query parameter? So what actually is a query parameter? Let's talk about that first. When might I use a query parameter? When is that going to show up? We actually see these quite frequently.
Change the URL.
Change the URL. So
Question mark.
yeah, so you got so that's how a query parameter shows up. But let's illustrate an example of what it might be used for. If I type in the word cats here, you can see that it says google.com, but then it also says a whole bunch of other stuff up here, right? A whole lot of other stuff up here, where this whole lot of other stuff is a bunch of query parameters, one of which, if I look in here, is this one. I know that's probably too small for you to read. In the back especially, it says Q equals cats. That's what I typed in the box, right? That's what I typed into the search box. I'm searching for cats. And so it's actually encoding that fact right in the URL. I'm looking, in fact, the rest of this stuff is not especially necessary. I could, I believe, remove most of it and just do Q equals cats, and look at that. I get the same kind of results back, right? And so you might be asking, well, then what the heck was all that other stuff? And to be perfectly honest with you, I don't know. I don't know. Google is doing some stuff, that is for sure, right? Google is doing all kinds of things like tracking what I'm searching for, right? Figuring out what ads it wants to display to me, things like that. So these other query parameters may have to do with those things. I'm not sure. That's just a guess. Google knows. I don't really know. It's not easy to discern what's happening here, right? But to include a query parameter on our URL, somebody mentioned, we put the question mark. I put a question mark at the end of the URL, then it's the name of the parameter equals the value that I want that parameter to have. And if I have multiple query parameters, what am I going to see? The ampersand show up. So there's one there, there's one there. So you can see there's multiple query parameters here, of which the only one that I directly had control over was the search term cats, right? Yeah, all right. What about a fragment? How do I include a fragment in my URL? Yeah. Pound sign, yeah, pound sign, or hashtag, or whatever you want to call it. What is a fragment? What is that used for? Anybody know? Yeah, good. It's something that the browser uses on our side, on the client side. We are the clients. I can show you an example that I'm sure most of you have used at some point or another. If I go to Wikipedia and search for something, what should I search for? How about cats? It'll take me to the page for cats, and actually I don't have a fragment yet. But one of the things that you see on Wikipedia page, right at the top, is a table of contents, right? And so if I look at one of these, maybe I want to see, I don't know, the size of cats. And I click on that, and notice what happened to my URL. I've got a fragment now. I see pound size. So that's telling me to navigate to this particular section of the page. This is commonly what fragments are used for. I can take a single page that has a lot of different sections on it, apply a label to each one of those. We can actually go into the source, or actually maybe even faster would be to open up, I'm in Chrome, not Firefox, but I could still open up the developer tools. And oops, where did there we go, size. And if I want to, actually I'm not as familiar with the Chrome developer tools, unfortunately. But now I'm kind of getting the hang of it. Top left, this guy? Yeah, perfect. Now I can select this one, and you can see what's the fragment based off of. It's based off of something that we've actually seen before. This guy right here. The ID. The ID is what's actually the fragment is pointing us to. inside of the page. So we talked about IDs last time. So I can use a fragment for that purpose. And next time you navigate Wikipedia, you can take a look at this and play around with it yourself. That's how they allow you to navigate through large pages in a quick manner with the table of contents. Any questions? There's one other thing on our list to talk about. A port. How do I include a port in a URL? I use a colon, and then I put in the port number. What is a port? That's something worth discussing as well. What is a port? If it makes you think of like boats or something, then
Like an entry?
it's like an entry point, yeah. It's like an entry point. So my computer has a whole bunch of different pathways to get in. Those are called ports. Those are called ports, or you could think of them as like communication channels with the outside world, right? Which port am I going to use for navigating web pages in a browser? Is this in the prep work? I thought it was.
80 is the default.
It's 80, yeah, it's 80. So if I'm browsing around online trying to access stuff, I need port 80 on my computer open. That's used for web traffic. There are other ports that are used for other kinds of traffic, other kinds of communications. And then we need to be careful because remember, a port is an entry point into my computer. So if I have ports on my computer that are open, that's a potential entry point for attack for hackers and other, people with bad intentions as well. So just something to keep in mind. But yeah, at its very basic level, a port is just an entry point into my computer that we use to communicate. All right. What is a request? We talked about this actually last week, I want to say, but today's a good day to review this concept because we're going to be thinking about it a lot more in the coming days. What's a request? What is a request? It goes from the client to the server. So what am I requesting? I'm requesting a file of some sort. Could be a web page, something like that. There's multiple types of requests. In fact, there are two in particular that I'm thinking about. There's a GET request and a POST request. What's the difference? Yeah, exactly. So a POST is going to hide any information that I'm sending as part of my request. Whereas a GET request is not going to hide that information. That information is going to show up in the URL as query parameters. So it's just a matter of, okay, is this information all right for me to potentially expose to the outside world or not? Right? If I want to keep this information kind of hidden, I should use a POST request. We see this often when we use forms, especially if I'm filling out like username, password details. Those are going to be sent in a POST request because I don't want my password to be displayed in the URL, right? That's not cool. For other stuff that doesn't, matter so much, like I don't care if people know that I'm searching for cats on Google. So we can stick my search query right in the URL, and if somebody's looking over my shoulder, they'll see a bunch of cat pictures, and it's no big deal. It's all good. Yeah, what's up?
With the post, you can still see that information.
You can. Yeah, you certainly can see the contents of the post. That's correct. So if we truly want things to be secure, we've got more work to do, right? That's just the first step in securing our information. I think a better way of thinking about it is if I'm using a GET request, any data that I send back and forth is absolutely not secure. It's publicly accessible, open to the outside world. If I'm using a POST request, it may be secure. No guarantees, but it might be a secure connection. Yeah, what's up?
So just thinking about the difference between like the GET post and you're saying that the post is like more hidden, but you can see it in the developer too. So think about like the private browsing feature.
Yeah.
What would that still be like?
Yeah, so the question is with like private browsing features, would that be a GET request or a POST request? Honestly, I don't think the website is going to care whether you're using like incognito mode or whatever the case may be. As website designers, as website creators, we actually have the ability to specify whether some of our requests will be GET requests or POST requests. If I'm a user, if I'm on the client side and I type something into my browser, like in the address bar, that's what kind of request? That's a GET request every time. Nothing to be done about it, right? Absolutely nothing to be done about that. If I type an address into my browser, that's a GET request. If I click on a link that goes somewhere else, it might be a GET request, it might be a POST request. It's really kind of up to how the website is designed and developed. The website creators will hopefully choose the appropriate kind of request for the context that you're in. So if I'm dealing with a form, I mean, forms are where we most commonly see POST requests. If I'm dealing with a form like a login form especially, I'm going to package up the username and password in a POST request because I definitely don't want that to be exposed. If I'm just sending you to a different page and there's not even any other information that needs to be sent, then that's just going to be a simple GET request. It's good that you're thinking about these kinds of issues though, because they definitely matter, and we see privacy issues online pop up all the time. I'm sure some of you have been struggling like I have with databases and stuff on websites being compromised, and then, okay, I can't use that password anymore. Whoop, it's no good. It's out there. So we do need to take those kinds of things into consideration, especially now that we are developing websites ourselves. Great question. Any other questions? What's a header? Not the HTML kind of header. It's got more information about the request. Information like what? What might I see in a request header? Where it's being sent from, possibly. The date and time the request was made is a big one. Yeah. We're going to see that come into play a little bit later. Any other information? There's other information actually, not just where the request came from, but also like what kind of system the request came from. You might have heard of a term called a user agent. So anytime I make a request, it's also sending the fact that I'm on a machine running Windows, using a Chrome browser, right? Or if I'm on a phone, it'll say that I'm on a phone, you know, running a particular kind of browser. And so websites will actually use that information to decide how to fulfill your request. If I am on a phone, it might actually send me a mobile version of the website instead of the large version of the website, for example. So, you know, it is using that information. Cool. All right. So that I send out a request. What are some responses that I may get back? 200. 200 means what? That means everything worked. That means everything's good. What else? 404 is another common one. That means we didn't see it. We couldn't find what you were looking for. It's not there, right? I have no idea what it is. What else? 500. What's a 500 error do? You broke it. It's a server-side error, right? If I'm remembering correctly. Something went wrong, not on the browser side, but on the server side. And you're not going to see this happen very often, but you know the joke was you broke it, and that's kind of actually what it means. You made a request that confused my server so badly that it just like totally stopped doing what it was supposed to be doing. That's a really nasty one to see. Yeah. Any other ones you guys remember looking at? 300. What's 300? Yeah, so it was is that a redirect? I don't have the codes memorized, as you can probably tell, but they are categorized, right? So if they start with a 2, that generally means that things went okay. If they start with a 3, that means that, you know, we kind of ran into an issue, but we've figured out how to fix it and, you know, fulfill your request anyway. That's usually what something with a 3. If I see something that starts with a 4, that means we got some problems. And if I see something that starts with a 5, that means we got some really bad problems. It's usually what that means. Cool. What's the difference between a static and a dynamic web page? Yes, a static web page does not change no matter who's looking at it or what they're trying to do with the web page. One way of thinking about that, right? If I send a link to somebody and they go to that link, will they see exactly what I see? That's not a guarantee that it's a static web page, but it's certainly a clue that it might be a static web page. If I send somebody a link and they see something different than what I see, that is a big fat clue that it's a dynamic web page, because that web page is reacting based off of who is accessing that website. A classic example, right, would be Facebook. If I go to my profile on Facebook, I'll see a link at the top. It says facebook.com/profile, right? Something like that. If I send you that link and ask you to click on it, is it going to show you my profile? No, it's going to show you your profile, right? Because Facebook is dynamically checking to see who's logged in and showing the information based off of that, right? That's an example of a dynamic web page. A static web page is something that's not going to change. So, you know, we were laughing and joking around with the Space Jam website last week. That's a static web page. That information is not going to change no matter who's looking at it. If there are no user accounts involved, could, not guaranteed, but could be a static web page. I actually, you know, make static web pages for my work quite frequently. So here's web page for, you know, one of the classes that I teach, and this is very much a static web page. It's just got a calendar on it with all the dates and stuff that we're working on, right? And so if I want to, and it has a big effect on development. So if I want to change the content on a static web page, what do I have to do? Typically I have to go in and change the HTML, change the CSS, just like you're doing on HTML Me Something. That's an example of a static web page. If I want to change the code on a dynamic web page, if I want to change how it works, what do I have to do then? I've got an actual application now. It could be a Python application, that's what we're going to be using, or it doesn't have to be Python, it could be in other languages as well, but there's going to be actual code that's going to be executing to create the web page. And so I'll have to go in and not necessarily manipulate the HTML and CSS, although I might have to do a little bit of that, but I'll be manipulating the actual executable code as well, the Python, the JavaScript, the PHP, the whatever I might be using to develop my web page. Great. Just a couple more small topics before we switch over to today's walkthrough. What's DNS? What is that? DNS is, it's a domain name service. Yeah, that's what DNS is. Right. So let's think about it this way. You actually brought up a lot of good information in your answer there, right? Computers see the entire world as what? Binary, numbers, right? Computers think everything is a number. Literally, they think everything is a number, right? And it kind of is. That's a sort of philosophical topic for another day, but you know, that's how the computers see the world, as numbers. So, you know, computers are very happy to take you to a numbered address, and those addresses exist. They're called IP addresses. It's usually 4 numbers strung together, something dot something dot something dot something. It's an IP address, and every website you ever go to has an IP address associated with it. It's like an address on the street, right? What's your street address? Oh, I live at so-and-so, you know, Big Bend Boulevard or whatever the case may be, right? It's the same idea. Humans, not so great at using numbers for that purpose. Especially, you know, we used to memorize phone numbers, but we don't have to do that anymore because our phones do it all for us, right? So I can't even I hope I never get arrested because I would not know how to call my wife to come bail me out without my phone. It's true. Don't tell her I said that. You know, humans would much rather have text, would much rather have labels, human useful names, right? And so that's where DNS comes in. DNS associates a human-friendly name like Google or Facebook, right? With the IP address, which is where the website actually lives. So when I type google.com into my browser, what happens? It actually goes to the DNS server first and says, hey, do you know the IP address for google.com? The DNS server hopefully says, yeah, I do. Here you go. And then my browser says, okay, this is where my request needs to go. Here's the IP address, and then here's the request I want to make, and then it ships it off. And then the internet figures out how to navigate it to where it's supposed to go. It sees a request, processes it, and sends it back. Sometimes we run into DNS problems. Some of you might have seen this happen. This happens to me, not super frequently, but sometimes DNS servers have to get updated. So sometimes new websites occur, right? And they need to get their names added to the DNS. Sometimes a website will change its address for various reasons, right? And so the DNS needs to be updated to point to the new address. And so these updates take a little bit of time. They usually do them like in the middle of the night. I don't know how many times this has happened to you. I'm a night owl, so I'll be up at 2 in the morning, 3 in the morning. I type in Facebook or Google, and the internet's just like, I don't know what you're talking about. And it's like, what? Come on, man. Like, I was just trying to check my Facebook before I went to bed. They're updating the DNS, probably, is usually what that means. You give it a few minutes, and they get it sorted out. I know for a fact that Spectrum does it basically once a week at usually the same time. They'll update their DNS servers, and so if you have problems accessing websites during that time, it's usually what it's for, usually what's causing it. Yeah. Cool. And so when you make a website, if you want it to get put onto the internet where people can see it, what do you have to do? Has anybody done this before? Yeah. I see a hand. You have to get a domain name, right? You have to register for a domain name, which basically says I'm reserving this name for myself. And as part of that domain name registration, the company who you paid for that name will usually send it off to the big DNS servers so that other people will be able to look it up. But it takes time, right? You can't go to your domain name right after you buy it. You got to wait a day or two usually for that information to get updated, and then it works. Yeah. Last, but certainly not least, what is TCP/IP used for? We actually already talked about the IP part of this. IP is the Internet Protocol, the addressing. That's what IP address is, right? So what's TCP/IP used for? It's actually a very broad question. It's kind of like how much time do you have, right? We could talk about this all day, but there are some very basic things that it does provide for us. Does anybody know? I'm sorry? Networks and communication. So have you ever wondered like how information gets to where it's supposed to go? Because that's TCP/IP. That's its job. It makes sure that information gets where it needs to go. When I go to google.com, it figures out the path to get from our router, which is, actually the routers are on top of the posts, I believe, in this building. So get from our router onto the internet, which is, a big bowl of spaghetti as far as we're concerned, which noodles to take to get us to the right meatball and then back, right? That's TCP/IP in action. But it also does other things for us, like it makes sure that the request gets there and gets back. Like it guarantees that for us. That's another big role of TCP/IP. Sometimes things can get lost. You can make a wrong turn, just like we make wrong turns, right? This can happen. Sometimes things get lost. TCP/IP will see that, okay, this one didn't make it for whatever reason. I'm going to send it again and cross my fingers and hope that this time it makes it there. Stuff like that. That's what TCP/IP is used for on the internet. We can't really mess with it a whole lot. It just kind of does what it does, right? but it is important to understanding how the internet works. Cool. Were there any other questions or things from the prep work that you thought were confusing, or things from the prep work you were hoping I would talk about that I didn't quite get to before I switch over to today's walkthrough? Yeah, in the back. The purpose of what now? A query parameter, okay. So if I go to a URL and I don't use a query parameter, right? The server will see my request, oh, you want this file, and I'll just send it right back. If I send a query parameter along with that, the server could take that query parameter and use it to give me something different back than if I hadn't used the query parameter. So query parameters allow me to specify additional information with my requests so that the server can use that information to provide me exactly what it is that I'm looking for. The classic example being a search query, right? If I want to search for something, I'm going to use a query parameter to send along what it is that I'm searching for, so that when Google gets my request, it's not just like, oh, this person wants to perform a search. It's like, oh, this person wants to perform a search for bowling balls, right? And it looks up the information about what I specifically told it I wanted to know and sends that back. That's what query parameters are used for. Yeah. I don't know what the I'm feeling lucky button actually does. I mean, I know what it does. I guess I don't know how it works. That's a better way of saying it. I think it is just random. Yeah. But we can actually use it and see if it includes any search parameters or not. Let's try it out. So I'm feeling, oh, trendy. Whoa. Oh-ho. Oh. Google's trying to make search feel more exciting. I didn't know about that. No, I think I'm feeling lucky just pulls the top result and takes you directly to that page, correct? So if I search for cats, where's it going to take me? Cats the musical? Well, okay. Not exactly what I was hoping for, but I certainly understand why it would do that. So think about what happened when I hit that button. I sent the request. It actually still sent my search query along with it, probably as a query parameter. Yeah, you sure would in the developer tools. Yeah. Yeah, that's part of the problem. That's part of the problem, and part of the scary thing about looking under the hood is that you see a whole bunch of stuff that you maybe were better off not knowing about. Ignorance truly is bliss in a lot of cases, right? So network. So we can actually see the requests. So this is the network tab. This is in Google Chrome, although I think Firefox also has a similar option. So you can see the query parameters from this query, right? Well, okay. It's putting cats, but then you also see the next query parameter is I'm feeling lucky. So we're actually sending two pieces of information to the server. The fact that I want to search for cats and the fact that I clicked the I'm feeling lucky button, so that when it sends me the request back, it's not going to bother sending me the search results. It's just going to redirect me directly to the first page from the search results instead. And so you can see in the responses, right? The next thing that I got back was not a search results page. It was just the direct Cats the musical page. So it's doing all of that on the server side. Cool. And so actually you can see the status too, 302. Which one is that? I don't know. 302 response code. 302 response code is a common way of performing URL redirection, right? It didn't want to send me to one of Google's own pages. It wanted to send me to a different page, so it redirected me to the page right? Whereas if I had not clicked that button, I can go back and try again and just type in cats and then, oh, wow, thanks Google. Whatever. I closed developer tools. I don't know why I did that. So if I just do a regular search for cats and I don't use the I'm feeling lucky button, you can see that the status request for my search was not 302, but it was 200. I see your request. I'm going to satisfy it myself and give you back the search results that you're looking for. And here it is. These are all different parts of the search results. Cool. That was a fun little experiment. Any other questions? Yeah, what's up?
So the fragment, it's kind of along the same lines. Using a fragment, if that takes you, you said it is associated with an ID.
Mm-hmm.
Would that be different than if you put a label with a class or div in your CSS? Does that just work?
Yeah. So the question was about the fragments and the IDs, and if it would be different if I use the class attribute. I believe for fragments it has to be the ID attribute, not the class attribute. And there's a good reason for that. The ID attributes, what's the difference between ID and class besides the syntax? Like, what's the actual difference that we expect between those two? Uniqueness. If I mark something with one ID, I expect that to be the only thing that is marked with that ID. If I mark something with a class, I actually expect to probably mark multiple things with that class. That's the difference between the two, right? And so if I'm thinking about that in terms of how the fragments work, if I navigated to a fragment that showed up in multiple places, my browser would then probably get confused and say, I don't know which one you want, right? Whereas if I use an ID, I know that's the only one, so that must be the one that I want to go to. Yeah, which is why IDs are used for fragments. Good question. Any other questions? Cool. Let's start today's walkthrough then. This is the first walkthrough we've done for Unit 2. I actually would encourage you, if you have your laptop available and are able to get it set up, to follow along with me as much as you can. If you can't follow along with me for whatever reason, or if you get stuck or you get lost somewhere along the way during the walkthrough, that's all right. I'm going to tell you right now, there's a lot of people in this room. I've run these walkthroughs enough times to know that I unfortunately I will not have enough time to stop and help, individual people with all their problems, because it just eats up all the time that we have available. So if you get super stuck, if you get super lost, feel free to ask, but I may say, talk to me after, or talk to your TA after. I may push it for the sake of time. That's not meant to inconvenience you. It's just meant to make sure that we have enough time to get through the walkthrough together. So we're going to set up Flick List today, and we're going to start very basics, the very, very basics. We actually already have some stuff that we can use to get started with Flick List. And so what we're going to do today is basically get set up, get the Flick List code on our computers, and then set it up and make sure that we can run it. That's our goal for the walkthrough. And then for the studio, you're going to make some small modifications to it. And then we'll go through the studio results at the end of class today. Okay? So there is a repository online. I see all these questions. We've actually already talked about a lot of those questions. I want to start here at the project setup. There's a repository online that LaunchCode has put the Flick List stuff into. This is the repository that we're going to be using for the next 6 weeks. It's got all the studios in it and all the walkthroughs in it that we're going to go through for the next 6 weeks. So we need to get that code so that we can do those activities together. So that's what we're going to do today. If you haven't already, pull up this page. It's the Class 3 page on Canvas. If you go to Class 3, and you go to the studio, you'll be on this page, and I'm under the heading of Project Setup. First thing we need to do is grab the code. So they've given us a link to the GitHub page for Flick List. And let's check this out. Here it is. Here is flick list. And you can see it doesn't look like there's a whole lot of stuff in here. If I'm looking at this repository, I see there's a license and a README file, and that's it. It's actually a little deceiving. Why? Where else might I look to see if there's stuff in this repository? The branches. So if I go up here and look at the branches, you can see, oh, there's a lot of branches. You can see there's a whole bunch of studio branches, and there's a whole bunch of walkthrough branches, right? I don't need to mess with these for right now. I'm just making it clear that there actually is stuff here. There's actually a lot of stuff in this repository. We just can't see it all because we're not on the branch right now. But we're not gonna worry about branches yet. What I want to do is I want to grab the repository, and then we can talk about branches and using the branch that we want for a particular activity. So I'm going to click this big green button over here, clone or download, right? And there's a web address that links to this repository. So we're going to go ahead and copy that. And then the next thing we need to do is open up the command line. So if you're on Windows, you'll probably open up Git Bash. If you're on Windows, it's actually probably in your best interest to run Git Bash as an administrator. So right-click on Git Bash and run it as an administrator if you're on a Windows machine. If you're on a Mac, you can just use the terminal program. You don't need to worry about the administrator stuff. You can just use the terminal as is. Either way, copy this and open up your command line, whichever one it might be. Here's mine. I'm going to see if I can zoom in on this text so we can actually see it. All right, cool. For earlier assignments, we had you create an LC101 directory, right? So the first thing I'm going to do is go into that directory. I don't actually remember where mine is. Well, I do, but I want to double check just to make sure that I'm right. So how would I check to see what directories are available to me right now? LS. So if I type in LS, you can see I got a whole bunch of weird stuff in here. But there's LC101, right? So this is where my LC101 folder is. I don't know where your LC101 directory is. You know where it is, I hope. We asked you to put it in your home folder. You know, hopefully you did that. Maybe you didn't. I don't know where it is, but hopefully you do so that you know how to get there on the command line. For me, it's pretty straightforward. I just need to do cd LC101. Okay? And you can see the command line is telling me that I'm now in the LC101 folder, which is where I want to be. And I can look in this. I see, oh, I was messing around with crypto, I guess, you know, the other day. Right? That's all I have in here for now. So the next thing I want to do is I want to grab the code that's in this repository. So how do I do that? What's that called? It's a clone. It's a clone. So I'm going to say Git Clone. Let me see if I can make this text a little bigger. And then I'm going to paste in this address that I got. Uh-oh. What did I do wrong? Oh, I didn't copy it. My fault. Try again. Copy. Paste. There it is. So this is, I haven't executed this yet. This is what it looks like for me. This would actually look the same for you. The only difference being that you're in your LC101 folder, wherever that might be. I'm going to hit enter. And it goes and it grabs all the stuff. And if I run ls again, what am I going to expect to see now? Flick list. There it is. Flick list Flask. There it is. It's right there. Oh, why did you do that? Don't do that. I'm trying to make it bigger, not smaller. All right. So the next thing I want to do is I want to go into the repository because that's where we're going to do our work. And I want to just kind of poke around a little bit and see what's in there. So I'm going to go into flick list Flask. And you can see it's telling me what branch I'm on. I'm on the master branch. So if I hit ls here, I should expect to see the same things that I saw online, which are the license and the README, neither of which are particularly of interest to me right now. But the way that this repository is set up, there's a bunch of walkthrough branches and there's a bunch of studio branches. So the way that the workflow in this class is going to go from now on is for the walkthrough, we're going to check out the walkthrough branch for that given day, and we're going to do it together in class. And then when we're finished, you'll check out the studio branch for that day, and you'll continue where we left off. And what's often the case is that they build off of each other. So the studio branch will often have the walkthrough solution in it, right? And then the following walkthrough will have the studio solution in it, right? And vice versa. So we'll just keep repeating that pattern. That does mean if you want to, you can peek ahead and see the answers, but don't do that. Come on, guys. I trust you. So what that means for us today is that we need to get our first walkthrough branch. So how do I check out a branch? Git checkout, and then the name of the branch that I want, which, you know, I don't know off the top of my head, but I can go here and look at the branch list and see, all right, there's a branch called walkthrough1. That's probably a good place for us to start. It's probably, it actually says it also on the, you know, the studio page for today. I go down here a little bit lower, check out the walkthrough1 branch. There we go. It even gives us the command. Perfect. So let's do that. Wrong. I have two command lines open apparently. Walkthrough1. All right. I'm going to do that, and it says switch to a new branch walkthrough. Branch walkthrough1 set up to track remote branch walkthrough1 from origin. So that line, I know it sounds kind of cryptic. It's saying, oh, you checked out a branch, and I see that branch online, so I'm going to just assume that that's what you meant. Right? I assume that you're talking about that branch. And so now if I hit ls and see what's in here, oh, I've got a new file. There's a new file that was not here a second ago. So there's a main.py in this branch that wasn't in the previous branch, right? And so I can open that up, just take a peek and see what's in it. We can talk about this real quick, because this was covered in the prep work for today. Can I zoom in on this? Oh, somebody asked me if I could switch this to the lighter colors, and I forgot to do that. I'm sorry. I don't actually know how to do that yet. Code, yeah, code main.py. Where are the... theme. Perfect. I want the light theme. There we go. That's probably much easier for people to read, I hope. All right. Get these weird boxes out of the way. There's an update available, sure. All right. And so you already went through something kind of similar to this in the prep work today, right? This is not just any Python program, but a Flask Python program, which is a little bit different. What is Flask? It's a framework. It's a framework. What the heck's a framework? Yeah. Yeah. I agree with you that it's related to libraries and modules. A framework is a set of tools available to us to solve a particular problem. Or another way to think about it is, if I'm creating a website, right? There are some things that all websites are basically going to need. They're going to need the ability to set up different paths, right? And display pages. So a framework gives us the basic functionality to do those things so that I don't have to worry about that stuff and I can focus on what makes my web page unique from all the other ones. There's a very common phrase you'll hear in computer science at some point. This may or may not be the first time you're hearing it now. We don't like to reinvent the wheel, right? If somebody's already figured out how to do something, then I'm not going to sit there and try to also figure out how to do that thing necessarily. I can just use something out there that already does it for me. And then worry about the stuff that's different. Worry about the stuff that makes my website unique and special. So that's what a framework really is at a high level. It's going to provide the common stuff for us and let us just focus on the different stuff. And so we see some pieces here, right? And the prep work today went over what these various pieces are. What's this about, this line here? App.route. When I go to this is actually a path. This slash is the shortest possible path that I can possibly have. We actually have a name for this. We call it it's on the screen. It's the index. That's the landing page. If I go to your website, what's the first page that I see? That's the index. It's usually going to be, not always, but usually going to be at the path of slash. Or we might call it the root, right? There's lots of other things that might call it. So what this is saying is, all right, if somebody types in the name of our website into their browser and goes to us, what's the first thing that they're going to see? This happens to be the only thing that they're going to see because our website is very small right now, but as time goes on, we're going to add more and more stuff to it, and this will not be the only thing on our website. And so right now, what does it do? It says movie of the day is The Big Lebowski, and that's all fine and good, right? It's a little bit of HTML. We've got a header tag and then, a list. And then down here, I see app.run. So this is Python with a little bit of HTML mixed in, right? So how do I run this? That's the next step. I want to actually run this and see if I can get this page up and running on my computer. So what do I have to do first? Does anybody remember from the prep work? I know it says on the instructions, but... So, all right. So the suggestion was, let's run it. Python main.py. Nope. No module named Flask. I have to activate my virtual environment. So as part of the prep work, you were asked to create a virtual environment. If everything goes well, that should be the only virtual environment that you have to create. Although sometimes problems do occur, and you may need to abandon that one for another one. It happens. Hopefully it doesn't happen too much. I should have one on this computer. I went through the prep work before class. I got everything set up for today, so I should already have my environment set up. So how do I start it off? Source, activate, and then the name of whatever you called it, right? I followed the prep work, so mine is called Hello Flask. And it takes a minute. What does this actually do when I switch to this environment? Does anybody know? It's kind of the prep work sort of glossed over this part a little bit. A path for your environment. So set up a local server? Not quite. Let's think about it this way. As a programmer, I'm probably going to be working on lots of different projects, right? Not just one thing, but probably lots of things over the course of time. And some projects may require certain things in order to function. For example, this requires Flask in order to work, right? Another website that I'm creating may not use Flask. It may use a different framework or some other kind of library or something like that, right? So this environment, switching from environments, is basically a way of keeping all of those things together for us. I'm working on this project, let me load up this environment that has Flask and the other libraries that I need for this project. I'm working on this different project over here, let me load up another environment that has what I need for that project to run, which may or may not include Flask and the other libraries from the other environment. So it's a way of just kind of keeping your activities organized and sectioned off from one another, is the basic gist of it. Okay, so I've activated the environment, which for our purposes basically loads Flask. That's what we needed. You can see the error message is telling us, I don't know what Flask is. So I've loaded the environment. Hopefully it does know what Flask is now. So if I try the same command again, main.py, I'm hoping I get different results this time. Let's see. All right, this looks good. Running on HTTP. What's this guy? That's an IP address. What IP address is that?
That's internal.
That's my computer. That's my computer. 127.0.0.1 is a special IP address. It's reserved. It's called the loopback IP address. It's basically pointing at your own computer. So this website that we have just started is not on the internet, not even close. It's on our computer only, which is actually good, right? Because we're still working on it. It's not done. It's not ready. I don't want people on the internet to be messing around with my stuff when it's not done yet. So I just want to keep it on my computer for now. I can work on it. I can get it running the way that I want it to. And then when I'm happy with it, then, towards the end of the unit, we can talk about, all right, how would I put this on the internet? For now, we don't want that. So what I need to do then, if I want to see what's going on, is I can copy this address, go back to my browser and paste it in, and hopefully, hey, look at that. Movie of the day, The Big Lebowski. So it's, again, I've navigated to, this is just the host portion of the URL. That's all it is the host. There's nothing else after it, right? I don't see a slash, login, right? There's no path after it. So I'm navigating to the root. I'm navigating to the beginning of the website. So what it does is it says, all right, they're accessing the index of the website. It's going to go back to this file and say, have they marked any routes as being the one for this particular location, for this particular URL? And the answer is yes, I have. It's right here. That's being marked. That's the route for this particular location. All right, cool. Then I'm going to execute this function. I'm going to execute this code. And that's what we see. Are there any questions about that? Any questions? So, we can modify this, right? We can change this. I can add another movie on here. The Big Lebowski is fine, but actually I'm just going to take it off. You don't have to use that movie, right? You can pick whatever you want. I'm just kind of messing around a little bit. And if I save this, and if I go back and I refresh, what's going to happen? Oh. I didn't have to restart it. I didn't have to do anything, right? I changed the code. I go back to the website. Boom. It picked up the changes that I made. Is this an example of a static website or a dynamic website? It actually is dynamic. Is it very dynamic? No. It's about as it's got about as little dynamic stuff in it as you could possibly get, right? It is just barely not static, just barely. But it is in fact dynamic, and it's gonna get a lot more dynamic as time goes on. So we're gonna build a Netflix knockoff if you haven't, deciphered that already. Flicklist is gonna be our little Netflix knockoff. We're not gonna be able to actually watch movies on it, but we are going to do things like allow people to keep track of what movies they've watched or what movies they want to watch, give ratings to movies, things like you can do on Netflix, right? Those kinds of things. We're going to do user logins so you can have multiple people access the website and the whole deal. That's all coming up. That's what we're going to be working on for the next 6 or 7 weeks until the end of the unit. Let me just double check the walkthrough today, make sure I didn't skip anything that I was supposed to talk about. We did that. I think I covered it all. I think I got it all. Are there any questions before I turn you loose? Yeah, what's up?
So, function index gets called. How does that happen?
How does that happen? Yeah, so
Function has a different name, but it's still.
Oh, okay, good question. So if the function had a different name, would it still run? Well, let's try it. Different name. Okay, it's got a different name now. I can change this just to make sure that it does work. Make this something different so that we know that it still ran, right? What's another good movie? I'm drawing a blank right now. What? Kill Bill? I don't know. That's an all right movie. If I go back to the page and hit refresh, picked it up. Doesn't care what the function's called. No, the magic is actually this line right here. So to really answer your question, we have to understand what this line is doing. It's saying if somebody submits a request to access this path on the server, this specific path on the server, I'm going to execute whatever this function is. So this path is what we're requesting, right? This is what we're requesting. If I wanted to, I can mess around with this a little bit, right? I could change this to be something else. Movies. Now my path is different. So now if I save this and I go and I refresh the page, it can't find my stuff anymore because I didn't type in the path that I told it I wanted for that particular piece of information. Now I have to make sure that the path that I'm requesting matches. So if I type in, was it movies plural?
Yeah.
There it is. I moved it. I moved it to a different portion of the page, right? That's how it knows what to do. It's called the route. So I'm going to switch it back to how it was, just so we are not confused by that. I forgot to save. Whoops. All right. Just trying to put it back to normal. There we go. Cool.
Should we freak out if it's not loading?
Should you freak out if it's not loading? Just a little bit. We'll get you sorted out during studio. Yeah. What's up?
If you have JavaScript in your website without Python,
So the question was, if I have JavaScript in my website, but I'm not using Python or Flask or anything, is it considered static or dynamic? And that's JavaScript would be used to make dynamic pages, yes, typically. Now we need to be a little bit careful, right? I mean, just because something is dynamic doesn't necessarily mean that it should be dynamic or that it's a good use of it, right? So there are certainly ways to use JavaScript or Python to do things that just are flat out not necessary. We shouldn't make our pages dynamic just for the sake of making them dynamic, right? There should be a driving need for it. Static pages are perfectly fine. If I have a bunch of information that I don't expect to change very often, then a static web page is great. There's nothing wrong with that.
I would like just basic certain functionalities that you can't implement with HTML, like the user interface function.
And so anytime you bring other people into it and you want to have some kind of a back and forth with your users, there's your driving motivation right there. Static web pages aren't going to be so great for that. They're very limited in what they can do. So if I want to have a lot of user interaction, that's when I need to think about doing more dynamic kinds of programming, which is what we're going to be doing. Because those websites are just more useful and more fun to use in general, right? Static web pages are simple, but boring. So we're not going to spend a ton of time on them. Was there another question I saw somewhere? Yeah, what's up? Mm-hmm. Yep. Yep. Oh, yeah, what would I call this? That's a good question. What is this? It's an annotation. Anything that starts with an @ sign is an annotation. So it's not actually code. What it is it's a clue. It's a clue to the computer about what a particular piece of code should be used for, right? This doesn't necessarily get executed. It's not like a line of code that's going to run. It's saying to the computer that, oh, hey, this function is intended to be part of this route. And then the computer will make that connection for us. Yeah, what's up?
So as our website awesome.
You do. You have to add more routes. More routes, yep. And we're going to do exactly that over the next several weeks. We're going to have, I don't know, half a dozen pages by the time we're all said and done. Yeah. Yeah, what's up?
try to add a second function to see what happens.
Sure.
The second function that we get called. So say we want two functions to be called that do different things. Let's say that out of it. Could you do that?
So I can only have one function for each route, right? If I go to a web page, there's one thing that happens, right? There's one result that I get back. So I can make one function per route. That's actually a little misleading. We'll see a little bit later that we can actually have two, but we have to be a little bit careful about how we do it. I can have one for a GET request and one for a POST request. That's for later. We'll talk about that later. But in general, I'm going to have one function for each route. So I can't make a second function for this route, but I can make a second function for a different route. If I wanted to, just a quick example, copy this code and come down here. This is the same exact code, but I'll just put my movies route back up. Now I've got two pages. They're the same. They look exactly the same, but I got two of them. This page should work, and this page should also. Oh, shoot, what did I do? Oh, there we go. So there's the problem. Whoops. Different name. Same function name. I had to change the function. Thank you. Not index. I don't know. Not the best name in the world. All right, so darn it, I keep clicking the wrong one. All right, so now I have to start it over again because I crashed my program. Won't be the last time I do that. And now I can come back here and see, all right, there's one page, but I can also now go to my second route, which is movies, and I have the same page. They could be different though, right, if I change the functions. And we will be doing a lot more of that. We'll be adding more routes as time goes on. Yep. That was one of the things I was going to talk to you about. Oh yeah, I wanted to get you set up to start on the studio, because this is, so remember, we checked out the walkthrough branch and we did the walkthrough, and we're done with the walkthrough now. We are done. And so you're going to get ready to work on the studio. And so in order to do that, you need to check out the studio branch. So let's just real quick, as our last thing today, check out the studio branch and get you set up for today's studio. So this is running right now. First thing I need to do is make it not run. So Control C will get rid of that. And I'm going to check out the Studio 1 branch now, right? So Git check out Studio 1. And you can see, uh-oh, I got a problem. It's mad at me because I made changes to this, but I didn't commit them. I didn't commit those changes. So anytime I'm about to change a branch, it's a good idea for me to commit my changes. So let's do that real quick. I say git, what do I do? I have to add first. Git add, and then the name of the file that I want to add to my commit. Then I can do git commit. What else do I need? -m with a message. Walkthrough 1 finished.
What directory are you in right now?
I'm in the same directory that I've been in for the repository, Flicklist Flask. You can see it right here. Yeah. Walkthrough 1 is finished. So now I've made the commit. Do I want to push? No, why not? I mean, I could try, but I'm not allowed. It's not our repository, it's LaunchCode's repository. And LaunchCode doesn't want to have 100 and some people sending their studio work to the repository. That would make things very difficult for future classes, right? So we're not going to push, we're just going to keep things on our computer for this. And then I can check out, I should be able to check out my other branch now. Check out Studio 1. And there we go. And actually, as I did that, you can see that Visual Studio Code noticed that the file changed and loaded up the code for the studio today. So you can go ahead and get started on that. If you got stuck, if you didn't get the Git stuff working right, or you ran into some problems along the way, talk to your TAs or talk to me. I'll be floating around. I'd be happy to help you get unstuck and get started. If you didn't get stuck, then work on today's studio, and we will go through the studio at around 8 o'clock. So I'll see you all back here then.